So good evening. Welcome, Viswanath. Please unmute.
Good evening, Dr. Ushaa.
How are you?
All good? Ready to start?
Yeah. So a very good evening to all the participants who have come to attend today's webinar. We are going to have a very, very interesting webinar and an interaction from a very interesting person, very, very senior experienced person from industry. Let me introduce him. So here we have engineer Er.B.Viswanath, who is head engineering in Delphi TVS Technologies. Engineer Viswanath is an alumnus of Annamalai University, from where he did his bachelor's degree in mechanical and production engineering between 1985 and 1989. And also he is an alumnus of Imperial College, London, and where he has done his master's in advanced mechanical engineering. He was selected on campus by Lucas TVS, and when the company started a new diesel fuel injection equipment division, he was amongst the first employees. He started as a graduate engineer in 1989 and progressively worked his way up. The FIA division was demerged and is now known as Delphi TVS Technologies Limited, and the company has grown to a turnover of over rupees 1,000 crores and has 2 manufacturing plants in Chennai. And as I said, he is head of engineering in Delphi TVS Technologies Limited right now, and his responsibilities includes product design, development, testing and validation, and the company has only one technical center to cater all its manufacturing plants, and engineer Viswanath heads the technical center. And he has authored and co-authored essay papers on the subject of diesel fuel injection systems, and he is considered as an expert on diesel engines and fuel injection, and he has participated in several panel discussions, and he has a very, very keen interest in the cause of education and was an academic council of Hindustan University and also participated in the syllabus compilation meetings at Anna University, Chennai. And we are very, very honored and we are very fortunate to have you, Engineer Viswanath. And also I'm proud to say that we both studied in Annamalai Universities together in a different branch. And very happy to welcome you to this session of this webinar. And I request all of you to please mute your audio and video. Thank you. Over to you, Viswanath. You can share your screen.
Thank you, Dr. Ushaa. Good evening, all of you. I'm very happy to be here this evening in your midst. I normally like an audience where they're all sitting here talking to us, making the interaction more lively. But we have to get used to the new normal now. The new normal means talking over internet. And so we have got these webinars. I sometimes lose count of the number of webinar invites I get on various subjects. So we are here, all of us together here for one more webinar. Okay. So I'll just share my screen for you so that you can see it. Just give me a minute. I will do that. I'll take a small break now. I'll be back in a moment.
So participants, a small request, please don't ask for the feedback link. Definitely I'll be providing you the feedback link at the end of the session, and kindly concentrate on the session and try to learn whatever you can. And that is what we are here doing this webinar, so that I can educate you and we can learn a lot of things what is happening around. And he's such a senior person who has achieved a lot, and he has proved himself as a wonderful engineer. So he can, whatever he speaks, I think we can learn something from whatever he says.
Can all of you see my screen now?
Yes.
Okay, now you can see my screen here. A couple of days back when we were talking, Ushaa asked me for a nice topic. So I said, let's do future emission regulations and opportunities for engineers. Okay. The reason being, I knew that this topic was quite topical. People would be interested to understand what it means. But one thing I want to do is I want to tell you, this is only a cue card, which means this is only a prompt for us. This is not going to be the only subject that we'll be talking together. What we are going to be doing is we are going to be, one second, sorry. We are going to be talking about the trends that are there today, what it means for all of us as engineers going forward. I would like to wish all of you, I'm sure most of you are engineers here, I would like to wish all of you Happy Engineers Day. In fact, what happened was a couple of days back, Dr. Ushaa contacted me and said, do I have a message for engineers on the occasion of the Engineers Day? I was a bit preoccupied at that time. So I said, I'll do it at the next best opportunity. And that's where we are all here today. So the Engineers Day is celebrated to commemorate the birth anniversary of Dr. Er.B.Viswanath. Many of you may not know about him. People would have heard about him as to why we celebrate it on that day. But it's important for us to know some of our history also. For in many ways, Dr. Viswesvaraya was considered as India's first engineer. As you can imagine, at that period of time, civil engineering was the most important discipline because a lot of construction was going on there. So he was also in the same field of civil and irrigation and those areas. And he did a lot of work for various cities and states, etc. The biggest achievement for him was the construction of the Krishnasagar lake in Mysore in 1924. He was awarded with the India's greatest honor, the Bharat Ratna, in 1955 for his work on engineering and education. When I say education, you can also see the number of institutions he has been instrumental in opening or starting or under his patronage, what the government of Mysore did several years ago. This is all what we have. Now, why do I say all this? It's important for us as engineers to understand, to celebrate greatness. If you look at some of the biggest or the best achievements of the 20th and the 21st centuries, engineers have had a hand in each one of them, whether it is electrical distribution grid or nuclear power or radios, televisions, internet, plane travel, cars, automobiles, mechanization of agriculture, highways, phones, whatever topic you take, engineers have a role to play. So as engineers, we can all be very proud of what we have achieved and what we're going to achieve in future. I'm sure we'll have enough work for all of us going forward. There's no gloom and doom for any of us here. So let us take this opportunity to be happy. Let us promote greatness. Let us be happy as engineers. Congratulations and Happy Engineers Day once again to all of you. Okay, now coming to the topic, Dr. Ushaa has been very kind enough and given me a very good introduction. But just to summarize what she said also was, I completed my master's from Imperial College in London and my bachelor's from Annamalai University, where we studied together, Dr. Ushaa and I. I joined Delphi TVS, and now I'm working there as head of engineering. I'm responsible for design, development, testing. I have a keen interest in the cause of education, and I was on the academic council of Hindustan University in Chennai for several years. And I've also participated in some syllabus compilation meetings for them. We are all living in a volatile, uncertain, complex, and ambiguous world. This is where we are getting into the presentation now. Okay, it's called as a VUCA world. What is the meaning of VUCA? VUCA, VUCA. VUCA means volatile, uncertain, complex, and ambiguous. This is not peculiar to automotive engineering. It is common to a lot of fields. A lot of the entire world itself is going through a turmoil, not only because of the pandemic, even before that. Everything is volatile. Everything is changing. There's a lot of uncertainty going forward. The whole subject appears to be very complex. And is it all clear? No, it's very ambiguous. There can be many outcomes, many directions going forward. This is what is called as a VUCA world. But what is it that we can do? We can still remain in a VUCA world, but we can change the meaning. Volatile can be value. Can we add value? What value can we add together? Uncertain. There need not be any uncertainty. We can be unique. We can come up with unique solutions. I am saying Indians, engineers, anybody, we can come up with unique solutions. Each one of us can do that. I know things are very complex today, but do we need to live with complexity? We need not. We can work together. We can co-create many things. Is an ambiguous world? Yes, it is ambiguous there. But what can we do? We can take action. Once you take action, ambiguity goes away. Ambiguity remains only when things do not move. Once you start taking action, you come out of this ambiguous world and you start taking action, things start moving forward, it becomes more clear. That's what I mean. We need to move from a VUCA world to another VUCA world where we add value, we bring uniqueness, we work together, and we take actions. Now, why did we choose a topic of automotive industry? Quite simple. The answer is quite simple. I am from the automotive industry, so it becomes easy for me to talk about that. But more importantly, the automotive industry contributes nearly 7% of the GDP. India's GDP, we're talking about several $1 trillion of GDP. The automotive industry contributes nearly 7% of that. And if you look at the manufacturing GDP, people must be familiar with the concept of GDP, or you can go back and read about it also. There are, in GDP itself, there are many services, manufacturing, etc., all included. If you take only manufacturing GDP, the automotive industry contributes nearly 49% of that, which means nearly every second contribution to GDP is from the automotive industry. People may not know. If people know, it's something that we can be very proud of. India is the largest manufacturer of two-wheelers, three-wheelers, and tractors in the world. This is no mean feat. This is no mean feat at all. It is huge, huge. We make millions of two-wheelers, few hundred thousands of three-wheelers, and nearly 1 million of tractors we make. And what does it do? It provides 37 million jobs today. Just imagine, keep these numbers, whatever I'm saying today, keep it at the back of your mind, because it's very important as we go forward to understand the implications of what the world is going to see to all these. India is the second largest bus market. India is the third largest truck market and the fourth largest car market. And if you look at the component industry alone, we have been growing at 24% CAGR. CAGR is compounded annual growth rate. This is huge. This is huge growth for an industry itself as you take. If you take industry on its own, saying that the industry is growing by 24% CAGR over 30 years is a phenomenal achievement. And we have been doing it since 1991 when the economy was liberalized. You can see some pictures, graphs on the right side of the screen. Typically in all my slides, there are going to be pictures, there are going to be slides, graphs, etc., explaining what I'm trying to tell you. These are all studies done by various agencies across the world. In every study that you see here, you will find that India is expected to grow hugely. India is the yellow curve, yellow line in this graph here. We are somewhere here. If you take passenger cars, as I said, 2 to 3 million, 5 million, etc., that's where we are today. And we are expected to reach around 25 million by 2050. This is no mean achievement. If you take two-wheeler, again, India is expected to be the world leader in 2050 with nearly 70 million two-wheelers being produced. So India is a big market. Please remember. Does it mean that everything is fine? No. There are certain things that we need to understand. The transportation industry itself, what we call as mobility industry or transportation industry, is changing very, very rapidly. Now, what are all the mega trends? Mega trends mean things that work together, things that are enablers, things that macro trends that help you move forward. What are they? They are clean emission, better performance, or electrification, and the reason to drive forward, further, autonomy, communication, etc. I don't know whether you have noticed, there are three small icons at the top of my screen. It will appear on every screen of mine. The three icons here refer to green, connected, and safety. So green, connect, safety are the three themes that are going to be there worldwide any number of years going forward. It's not today, it is forever. That's why I have chosen to keep that. That is to remind us that is what as a world we are trying to achieve. It is not uniquely different. Everybody is trying to achieve the same thing. How we do it is what changes. Everybody wants to have cleaner emissions. We don't want to leave the world a dirtier place than what we came in, correct? All of us have responsibilities as citizens of this world to leave this place as clean or better than what we came in at. That's why we talk about cleaner emissions. Performance, we have to be performing better. Performance means what? Performance means using fuel more appropriately, not polluting it, not wasting anything, reuse. So many things are there. And then drive further. Are there better ways of doing things? That's what we have here. So these trends all converging together as we go forward. If you look at what are the major technology-driven disruptive trends, as you see on the title. Disruptive trends means something which disrupts the flow. You are expected to operate in a certain way. Suddenly you find that things are not going the way you want because it has been disrupted. These disruptions are good, some are not good, but mostly going forward, it will continue to be good only. But what are they? There are many disruptive trends on the automotive side. Emissions, diverse mobility, electrification, autonomous driving, connectivity. These are all the major headlines that you see, which are disruptive trends affecting how the automotive industry is going to move forward. I will explain all of them in my subsequent slides. Just one more point I want to tell you. If any of you have got any questions, please write it down. At the end of the session, type it into the chat box. I will pick up the questions from the chat box and answer so that there are no disturbance at all between people starting to talk, etc. So it's easier to operate that way. Just as we're starting to see some things, please mute. Thank you. Okay. Emissions upgrade. Emissions upgrade is the biggest disruption as far as automotive technology is concerned. Now we come to the topic of emissions. Measurement of vehicle emission is what I'm saying here. What are the pollutants that are regulated? People know that what goes in is a carbon fuel. You take either diesel or you take petrol or gasoline, as it's called. It's basically a hydrocarbon. It's a hydrocarbon mixture of various combinations. You oxidize them, which is oxygen, which is burning them. And what comes out is carbon dioxide plus power plus a lot of pollutants. What are these pollutants? Not everything that comes out of the exhaust is regulated. The pollutants which are regulated are the four ones which I've captured here. HC, hydrocarbons, CO, carbon monoxide, NOx, oxides of nitrogen, various oxides of nitrogen like N2O, NO2, etc. They're all collectively known as oxides of nitrogen. PM, which is particulate matter. These are the four pollutants which are measured, regulated. Now, how are they measured? I've taken here a typical example of a vehicle, car-like application. The norms are very similar for big trucks and buses also, but they're tested slightly differently. But it is suffice to say for the moment today that there is a procedure to measure and check. Okay, just take that information to you today. So the cars, how are they measured? You run a vehicle on a chassis dynamometer. Now, what is a chassis dynamometer? A chassis dynamometer is something like a treadmill. All of you must be familiar with treadmill. People who do a lot of fitness exercises, they walk on a treadmill, they run on a treadmill, which means they keep moving, keep walking, but they don't go anywhere because the bottom, the belt below them keeps moving in the opposite direction so that they stay in the same place. A chassis dynamometer is exactly like that, which means what you do is you place a vehicle, the wheels of a vehicle on rollers, what you call as rollers. And as the vehicle starts to move, the rollers will move in the opposite direction. They will absorb or break the wheel. So this provides resistance like a road. So you can actually see some pictures of a vehicle being tested on a chassis dynamometer on the bottom of the right of your screen. You can see the vehicle here. Sorry, some message I've got here. Okay, you can see do all of you see this message or it's only me here? This meeting has been upgraded by the host and now includes unlimited.
No problem, go ahead.
Okay, so you see the vehicle here, and the vehicle is run on rollers, and as the roller moves, the vehicle moves, the rollers will start rotating in the opposite direction, and then you tend to run the vehicle there. So the vehicles are run on a standardized test cycle. This is the test cycle that we have here. This is the vehicle speed on the y-axis, and on the x-axis we have got time here. So through a particular time cycle interval, you run it through a standardized cycle. And what you do at the end of the day, you run it through the standardized cycle, you collect the emissions, you measure them. Now, what is the benefits of doing that? If you do a standardized test, it's easy to regulate it, which means I can say a standard cycle, so much of emissions is possible. Because I know when I test the vehicle, I'm going to get so much of emissions. I start putting a limit on them. So it's easy to regulate. In anything that you do normally, there is a standardization aspect of it. And this helps us to regulate, bring up rules, bring up limits. Now, what is the drawback? You follow a standard cycle in the laboratory, but when you go on the road, you don't follow the cycle at all. You drive as you can because of the traffic or because the road is empty. So there is some difference, or there are major differences between the lab and the real world. So this is the drawback. Now, if you look at emissions in India, the emissions in India started as early as 1984. It is not the way it was at that time. It was a simple Motor Vehicle Act for Maharashtra. And then 89, we had free acceleration smoke being limited, 91 smoke being limited, 92 gaseous emissions, 96, etc., etc. These are all numbers, dates available, not important. The important thing for us to know is it started as early as 1984. Of course, in other countries, it started much earlier. But to be fair, India was not making too many cars at that time. So these things were not very important at all for all of us. There are things which are more important than this. Now, what are the norms? India follows the European model, which means the test cycle that we have, the limits that we use, these are taken from the European model. So you have an equivalent, like you have a European Euro 1. The same thing in India is called as BS1 or Bharat Stage 1. So Europe today, if it's Euro 6, India is Bharat Stage 6. Okay. As I told you in my previous slide, the items that are pollutants that are regulated are hydrocarbons, oxides of nitrogen, carbon monoxide, and particulate matter. I've shown the progression of emissions here. This was a window for BS2. This is a window for BS3. This is a window for BS4. And what India did was, a couple of years back, India boldly declared that we are not going to go step by step. We are not going to go into BS5, Euro 5. We are going to jump straight to BS6. So that's what we did now. We went from BS4 to BS6, and you see that the window has become very, very small. When I say window has become small, what does it mean? It means that the limits are very tight, and going through the limits is going to be tight for all of us.
Let me see the size of the.
Okay. Sorry, somebody, can you please mute?
You carry on, I'll take care.
Yeah, okay. Dr. Ushaa, how do I remove this thing in the middle, the note that I get about this meeting? Because it's right in the middle of the screen. Yeah, now it's better for me. It's better for me. I was not able to see it. So this is the progression of the Indian emission norms. We talked about BS2, the window there. These are just two pollutants that I've taken for diesel vehicles. And we are here today in BS6 in 2020. So since 2000, 2001, the oxides of nitrogen pollutant from a vehicle has been reduced by 89% today. And if you look at the particulate matter, it has been reduced by 94% today. So you can say India has come a long way since we started emissions regulation. Vehicles have become cleaner. People might still say, all of you might be still thinking, what am I saying when I see all those vehicles belching out smoke there? If you don't maintain a vehicle, obviously it will continue to perform badly. But if a vehicle is maintained well, you can see here, we have made significant progress in the last 20 years, going from a BS2, BS1 to BS6 today. And today we are not far away from Europe. If you compare the emissions worldwide, in 2020, this is where we are today, India started BS6. Europe started BS6 much earlier. USA is at a different norm. I said we follow the European norm. For us, it's better to look at that. So effectively, we are now catching up with Europe, and going forward, we'll be there. The difference would be about 3 to 4 years only between India and Europe going forward. This is a very, very big achievement, thinking that we are a developing country as compared to Europe, which is a developed country. China also has its own set of norms. China is now at what is called as CN6A. Now, what is Bharat Stage 6, which is where we are today? Okay, I'll just give you a short primer on that. I won't talk too much details because there are more subjects that we need to cover. Now, as I said, if you take a small vehicle, which is less than 3.5 ton gross vehicle weight, which is like a car or a SUV, these type of vehicles fall in this category. You follow the standardized cycle. You have these emission norms here. The vehicle has to pass within this box, which is in the small box here, to be eligible to be cleared for production. Okay, this is the box that we are talking about here. Now, is that the only requirement? No, it's not the only requirement. Vehicles also have to pass two other requirements. One is known as OBD, onboard diagnostics, and the second one is RD, also called as real drive emissions. Okay, we'll talk about that later, but more importantly to tell you that vehicles as they are being produced are becoming cleaner, is what I told you here. OBD, what does it tend to do? It tends to help you maintain the vehicle over a period of time. If there are any problems, it will immediately report it. And real drive emissions, you remember I said that one of the drawbacks of running a vehicle on a chassis dynamometer recording the emissions, it leads to some difference between the lab and the real world. RD is expected to bridge that gap. So which means any vehicle certified for BS6 has actually qualified for this, and this. Okay, so you can see how much work has happened in the last 3-4 years to make all our vehicles very clean today. If you look at some of the numbers, if you look at some of the technology that we use today, it is no different to the technology that is used or available in Europe at this point of time. This is a major achievement from the automotive industry, and people in the industry, people who have been associated with it, are very proud of this achievement, both from a vehicle manufacturer's perspective and a technology provider like Delphi TVS. Now, I talked about BS6, I talked about the pollutants, I talked about the limits, etc. Now, how is all this achieved? Now, you have an engine, you see the engine on the left here. Engine produces certain pollutants. However much you try to reduce the pollutants, there are something which is going to be coming out of that. It passes through what is called as a diesel oxidation catalyst, DOC. You see here, hydrocarbon, carbon monoxide, particulate matter, and NOx. The 4 pollutants, as I said, which are regulated. Now, as it passes through the diesel oxidation catalyst, the hydrocarbons and the carbon monoxides go away. They are oxidized. Once you oxidize, they become carbon dioxide and they become harmless. So what remains is PM, particulate matter, and NOx, which is oxides of nitrogen. Then you pass them through a diesel particulate filter. So this was diesel oxidation catalyst. This is a diesel particulate filter. What does a filter do? As you can imagine, the filter removes the particulate matter. It filters it out. It operates like a normal filter that you use anywhere else in your lab, in anywhere, any other premises there. So what comes out of the DPF does not have PM. So you can see it has become lighter now. So you started with 4, you removed 2 at the first step, then you removed 1 more at the second step. Then after that, what you have only oxides of nitrogen. Now, how do you remove the oxides of nitrogen? You have a facility called as SCR. This is selective catalyst reduction or reaction, where you inject ammonia into the exhaust stream. Really, you inject ammonia liquid, you inject into the system, but you don't do this just like that. You have a permitted quantity, you measure it and you inject it. This injected ammonia sits on the surface of the SCR catalyst. Then as the NOx comes out, the SCR removes everything. So the SCR removes all the NOx that is coming out of this place. Because we have injected ammonia here, and there could be some mistakes, some errors where you have injected more. So you have ammonia that could remain. It's not necessary to remain, it's that it could remain. That is removed by what is called as a slip catalyst. So what comes out at the tailpipe end is absolutely free. So you don't have hydrocarbons, you don't have carbon monoxide, you don't have PM, you don't have NOx, you don't have ammonia. This is how the system works. As I said here, it's really a chemical factory out there. You can see now, you can see convergence of technologies, convergence of disciplines. We were mechanical engineers, we were combustion engineers. Slowly we became chemical engineers. Slowly we started doing something else. It's a chemical factory outside of the engine. And these are typical exhaust from various vehicles which are used today. You can see the tailpipe is no longer a simple pipe. Earlier we used to have only a silencer. In many vehicles in the past, people would have seen there was only a silencer to reduce the noise. Today, silencer is an option. We have so many other gadgets before that. I'll just go through this once again. This is the engine. What comes out of the engine are the 4 pollutants: hydrocarbon, carbon monoxide, particulate matter, and oxides of nitrogen. As it passes through the diesel oxidation catalyst, 2 of them get removed. PM and NOx remain. You pass them through the DPF. The PM remains. PM goes away, NOx remains. Then you inject ammonia here. It passes through the SCR catalyst. NOx gets removed. NH3 remains. You remove it through the oxidation catalyst. Now, all what I'm saying appears to be very simple, but it is a bit complex. A lot of work needs to be done by development engineers, R&D engineers to make it all work. But this is how simplistically it works for just for your all the information. Okay. Now, I said we need to talk about 3 things which are required for the vehicles to pass through. One was emissions, I mentioned. Second one I said was onboard diagnostics. Then I said RD. We'll come to that later on. First, onboard diagnostics. What is onboard diagnostics? You can understand already there are 3 words there: onboard, which means on the vehicle itself. Diagnostics, all of you can understand, is to check the health. You do health diagnostics, you do so many diagnostics. It's like that. It is a feature that allows detection of any malfunction. You've got so many electronic sensors, actuators in a vehicle today. They're all connected to a control unit. If any of them malfunction means do not work well, do not work the way they're supposed to work, they will lead to an increased emissions. Okay. If they lead to an increased emissions, the very purpose of clearing the emissions, starting production is lost. You don't want to do that. You want the vehicles to remain as good as what they were at the time of production. So what do you do now? If there is a malfunction, if you see it, you come up with a lamp. Now, what is this lamp? This is a malfunction indicator lamp. You can see this looks exactly like the engine picture that we saw on the previous slide. It is what is called a check engine or a malfunction indicator lamp, or a mill lamp, M-I-L, mill lamp. So this mill lamp, as soon as it comes up, you know there is some malfunction in the vehicle electronics gadgets, which is causing the emission to go beyond a limit. Now, does it measure emissions? No. Please understand, onboard diagnostics, it picks up malfunctions that lead to increased emissions, but they do not measure emissions at all. Then Is there an oxymoron? Is there a contradiction? No. During development, the engineers actually create all these faults, create a lot of faults and see which fault leads to increased emission. For example, you have a sensor. That sensor's short circuit causes an increase in emissions. So what they do is they record it in the system. So tomorrow when the vehicle runs, if there is a short circuiting of that sensor, immediately it comes up as a malfunction indicator. Why is that? Because we know from our previous testing that short circuiting of this sensor will cause emissions to go up. I have not measured emissions, but I know by experience, if this fails, emissions will go up. That's how OBD works. There could be some sensors where even when they fail, they do not exceed the limits. It's okay, fine. You don't need to do anything for that. What you need to do is you need to pick up all the faults which cause emissions to go beyond limit and highlight them. What else is the feature of onboard diagnostics? It's all standardized. The fault codes are common. You can see here, the fault codes are listed like this. So if you have a P code starting with the letter P, it means it is a problem in the powertrain. It's a problem in the powertrain which causes your emissions. And what happens? You have a scan tool here. You have a scan tool here which I've shown. This is what is called as a universal OBD connector. Every vehicle should have this connector. Okay. All you need to do is you need to plug in this scan tool into the connector and you can read if there are any faults, any malfunction has occurred or when it occurred. The system is supposed to record when a malfunction occurs, at what mileage it occurred. So the vehicle mileage, the fault code are all stored in the system and you can query them. That's why I said a protocol. You have a protocol to access that information. All this is standardized. So you can pick up any scan tool, you can insert it into any vehicle OBD connector socket and you can read the information. Do vehicle manufacturers share all the information? No. What they do is vehicle manufacturers in their control unit have got multiple layers of information. Only the information that needs to be shared is provided in a layer called as an OBD layer. And in the OBD layer, you can access the information whenever you want. Anybody can access it. Other areas are strictly prohibited. You can't enter them at all. OE manufacturers, vehicle manufacturers will not allow you to read what is there inside. But by rule, they are supposed to allow you access to certain areas in the ECU, which is what they have done here. So as I said, this is common. Everybody should have it. Fault codes are same. Scan tool is common. Protocol is available. We can talk. Next, real drive emissions. Now, what is this real drive emission? As it is very clear, obvious from the title, a car is driven on a public road and you drive it under various conditions. You install equipment on the vehicle that collects actually the pollutant data. You can actually measure the pollutants unlike anything that we did in the past. Here, the testing agency actually fits what is called as the portable measuring system in the exhaust system of the vehicle, runs the vehicle on a public road, and actually checks whether the emissions are still within limit or not. Now, by RD, we talked about it previously. We said it is not representative of real world condition. Not only that, you need to measure it under different operating conditions. Now, the cycle, as I said, one big advantage of a standardized cycle is it's easy to bring rules, easy to bring limits. But here, if it's not representative, it is a drawback. So you need to fix it. So that is what happens here. The vehicle is run different altitudes, different temperatures, different speeds, different types of roads, and then you measure the emissions. So here again, they have come up with rules so that people are able to measure it correctly. They say a trip should be a minimum 90 to 120 minutes. There should be a certain limitation on the road, what speeds you drive at and what temperatures you drive at. This is the European norm. Okay, this is the European norm because we adopt from Europe. This is what Europe is following. One other reason why RDE has come in is because there are certain vehicle manufacturers who employ what are called as defeat strategies. Now, what is the meaning of a defeat strategy? A defeat strategy is one which senses that if you're testing the vehicle in a cycle or not. So what they do is, if you're running the vehicle on a cycle, they run the vehicle on a particular program. So the vehicle emissions are very low. When the vehicle goes on the road, what they do is they employ a different strategy so that the vehicle behaves very differently. It gives better performance. So what happens is, it becomes a defeat strategy. You are defeating the purpose of emission regulation. You regulate it in a particular way, but you drive in a different way. So to avoid all that only, the people have come up with this RD requirement where you have to test it on the road as well and certify it. These are pictures from one of the vehicles done by our team in India. You can see all the gadgets fitted on the back of a vehicle. The vehicle is, the exhaust is instrumented, and then you have got a laptop, etc., connected to all the analyzers here. You can see some differences between India and Europe. I say India takes information from Europe. It is modeled around Europe, but we take certain information. See, our temperatures, our operating conditions, our speeds are different. So what we have done is, we have taken information from here and we have modified quite significantly in terms of the operating conditions to which the vehicle has to be tested, what speeds we need to operate at. For example, Europe, low speed means 0 to 45 kilometers per hour. Whereas for us, it's 0 to 35, because in Indian cities, speeds can be significantly lower than what you have there. High speed for them is more than 80. For us, it is more than 55. So you take information from Europe where the model is working successfully, you adapt it for India, and that's what we have done here. So we talked about emissions, we talked about OBD, we talked about RD. These are three requirements for certification of BS6. Now, is that the only thing? As far as emission is concerned, yes, that is the only thing. But what other norms are there? There is something called as a CAFE norm. What is CAFE? CAFE is corporate average fuel efficiency. Okay. What is the purpose of that? The purpose of that is to reduce the fuel consumption. Simplistic answer, it reduces the fuel consumption. What you do now is, just as you have a norm for emission reduction, you have a norm for fuel consumption. You say the fuel from a vehicle should not exceed this number. Now, how do they measure this? Similarly, they do it on the cycle only. And in the cycle, they run the vehicle, they measure the emissions. They measure the fuel consumption. They use CO2 as a proxy. They don't measure fuel economy directly. They use CO2 emissions which are coming from the exhaust as a proxy for measurement. So you know a CO2 number, CO2 grams per kilometer. Once you know that, you can convert it into fuel economy. So simplistically speaking, if higher CO2 means higher fuel consumption, lower CO2 means lower fuel consumption. Now, why is all this important? As I said, it has importance to reduce the greenhouse gas production, which means reduce the global warming. Additionally, for India, especially for India, it helps us to reduce the import of crude oil. You know, we import tons and tons of crude oil. So this will help us a lot to reduce the fuel consumption. Not only that, India has entered into what is called as a global warming limit, COP. COP 15 is what we have signed up for in Paris 2 years ago. Our Prime Minister has signed up for that. It basically means that we are supposed to take certain measures that reduce the CO2 emissions. The CO2 emissions can come from various sources, from power production to vehicle exhaust, etc. This is as far as the vehicle exhaust is concerned. CO2 norms reduction for other areas like power plants, etc., somebody else will be taken care of. But all of us have a collective responsibility as far as COP15 is concerned, which is the Paris Agreement which our government entered into to reduce the global warming. I have shown here what this means for fuel consumption average. Now, how is it defined? The fuel limit or fuel economy limit is defined based on the mass of a vehicle. So if you have a lower mass vehicle, the CO2 that can be allowed from that is lower as compared to what which is higher. Is it fair? Yes, it is fair, because you expect a vehicle of this weight to be releasing more So because they will still find it difficult to meet these norms. Now, this is 2017. This is 2022. What is coming next? So between 17 and 22, we are going to be seeing a 17% reduction going forward from phase 1 to phase 2. But how does India compare with Europe? If you take the norms that are existing today, which is Europe 2015 and India 2017, you can see EU is in green, blue is India. India continues to be higher than them, which means we allow more fuel consumption as compared to Europe. This difference actually becomes bigger going forward. India 2022 is not as stringent as Europe 2021. We are catching up. We'll take some time, but we'll catch up there. So we talked about fuel consumption. We talked about emissions. We talked about OBD. We talked about CAFE norms. We talked about RD, etc. Now, what happens with the diesel engines? CO2 benefits. Why have I put it here? I have put it here because CAFE norms impose a certain penalty in Europe. Like you have a limit. Once the limit is exceeded, every vehicle manufacturer has to pay a penalty. Coming forward, which means from Euro 2021, next year onwards, Europe, the vehicle manufacturer will pay nearly €1, 14 euros for every gram of CO2 above the limit. I repeat, for every gram of CO2 above the limit, the vehicle manufacturer has to pay 14 euros. Now, if he makes millions of vehicles, you can understand he has to pay 14 into millions for every car that he produces. It is huge. It is a big penalty that we're talking about. Now, what we see here is diesel engines, by their inherent nature, are very thermally efficient. Typically, the fuel consumption between a diesel and a petrol engine, diesel engines are better by about 15 to 20%. Even going forward, even with BS6, Euro 6, etc. So typically what happens is having a diesel engine in your mix of vehicles will help you to reach the target. Now, people have worked out how much work, how much CO2 reduction has happened over the last so many years. For example, you take this 2009, okay? The vehicles produced in 2009, I'm talking Europe, because India, the penalty system has not started. It will also come. But this is only a forerunner for us, this is only an example for us to understand. In 2009, the vehicles that were produced less than 5% less CO2 as compared to the previous year. If you look at 2016, vehicles produced or vehicles manufactured, vehicles sold in 2016, passenger cars sold in 2016, produced 1% less CO2 than the previous year. But you will see in 2017, it actually went the other way, which means vehicles manufacturers sold in 2017 actually produced more CO2 as compared to the previous years. One reason was diesel sales started reducing. And the impact is straight away seen in the global fleet. When you have a reduction of diesel vehicles being sold, automatically the global fleet average CO2 increases. Now what happens is, from 2018, for the next 3 years, the vehicle manufacturers have to continuously reduce fuel consumption by 5% every year or 6% every year if they reach the target. This green line is what refers to that. Green bar here shows that if they have to reach the 2021 target, vehicle manufacturers have to reduce fuel consumption of the vehicles produced in the next 3 years. From 2018, I'm talking about 6% every year. This is very, very aggressive. And the only way to do it is to have more diesel engines in your fleet. And that's what we will see going forward also. Okay. I think we're running short of time, so I'll try to skip a few slides also. If all of you have read this, the reports of my death are greatly exaggerated. Now, apparently, Mark Twain went from US to London. And when he went there, somebody picked up a news and they said that Mark Twain is no more. So Mark Twain sent a note back to the people who wrote it and said, I'm still alive. The reports of my death are greatly exaggerated. Why am I saying that here? It is just because IC engines are not going to die in the near future. Okay, don't ever think that IC engines will die. IC engines will continue. If there are mechanical engineers out there, combustion engineers out there, you can continue to be happy. IC engines will remain. People have done, many consultants have done a lot of studies. What do they all show? They show, yes, electrification is coming in some form or the other. Vehicles will continue to have a different mixture of vehicles. But even in 2030, which is 10 years from today, 80% will still have a combustion engine. You see here, only here we are talking about pure electric vehicles. Remaining everything has some form of a combustion engine, which is what leads us to the next topic. So, as I said, IC engines are here to stay. They will not go away. Electrification will come, but they will not substitute IC engines totally. Which, as I said, leads us to this next topic, which is electrification. A simple diagram here to show how the whole thing works. Okay, on the top you've got an IC engine. You've got chemical fuel. You see chemicals here going into a tank, going into a fuel injection system, burning and producing torque. In the case of an electrified engine or electric vehicle, you have a battery pack. You have an inverter. It converts it into an alternating current. The alternating current goes into an electric motor, which provides torque. Ultimately, it ends up with torque, but how you produce it, either through chemical energy and combustion here, or through battery pack conversion, is what differentiates between the two. There is a huge push towards electrification. Okay, why is that happening? It is because there are regulatory norms which are making it difficult for IC engines to survive on their own. We talked about emission norms, we talked about CAFE norms, we talked about OBD. All this is making it very, very difficult for IC engines to manage on their own. Some form of electrification is required. Higher battery capacity. Batteries produced today have higher capacities. They're coming down in price. Charge interval is increasing. The charging infrastructure is improving. In many countries, you can find charging infrastructure available everywhere. You see a picture on the right side here. This is a Tesla car. Okay, a few thousands of euros, thousands of dollars. And this is an e-rickshaw in Delhi. People who have been to Delhi know about it, or people who live in Delhi know about it. This is this e-rickshaw, highly popular, very, very popular. It sells for around $2,500. And we have sold more than 1.5 million three-wheelers in India in the last couple of years. If you look at this, last year, India sold 2,000 cars, electric cars, in a market size of 2 million. So electric vehicles have not come in a big way. They are very small population today. In a market size which is 2 million, 2 million vehicles are there. 2 million is 20 lakh vehicles are there. India sold only 2,800 cars, electric cars. You can see the big disparity between the two. But it is catching up. Now, what makes these e-rickshaws very popular? It is basically a make in India concept. Okay, it is not something that we have imported. It is a local technology, but it has been made in such a way that is very attractive. You don't have any fancy battery here. It's a very simple battery. What the rickshaw man does is he drives throughout the day. At the end of the day, he comes in, plugs it in his home. Throughout the night, it gets charged. Next day morning, he starts off again. Now, what happens is nothing major to invest for him. Operating costs are very low. The charging infrastructure is his own home plug points. And cost is not very severe. It uses only a 12-volt battery. So speeds are not very great, but this is good for India. This is good for a city like Delhi where pollution is a problem there. So such vehicles help us in a big way. So people had to be innovative. People have to think out of the box to make this electrification concept work in India or anywhere else for that matter. Electrification architecture, it spans from a simple start-stop on the left-hand side, starting at 12 volt, going to a mild hybrid at 48 volts, to a full electric vehicle. It spans multiple versions here. And this shows you how much of CO2 reduction is possible. For example, in a plug-in hybrid electric vehicle, you can have 100% CO2 reduction from a vehicle because it doesn't burn anything. It does not mean that the electric vehicle is all clean. It's just that the CO2 production happens elsewhere. Just imagine you are running in a country like India, you produce a lot of power using thermal power stations. You produce CO2 there. So which means we are polluting at the place where we manufacture power. But at the place where we use it, we don't pollute it. So if you want to have a total comparison or a good comparison, you should do a well to wheel, as they say, from the time oil is taken out from the well to the wheel. So in the case of electrification also, from the time it is produced, how it is produced to the time it is used. If you use, if a country uses renewable energy, like some of the small European countries do, then having electric vehicle there and using renewable energy for electric production makes a lot of sense because you don't pollute at all. You don't have any CO2 production at all there. There it makes a lot of sense. This is a simple 48 volt mild hybrid structure. So the system operates with a belt driven or small motor attached to the system. This belt driven, it reduces pollution, it improves the fuel consumption, it gives a torque boost. It's also a very small battery pack compared to a full-fledged hybrid structure. So it is becoming very popular worldwide. Many European countries, you find 48 volt systems running. A 48 volt system has two systems. You have a 48 volt system operating a small motor. And then you also have a 12 volt system, which runs the other architecture, other electrical parts. The position of the motor, in this case, what we call as a BSG, this determines various configurations of the mild hybrid. So you will hear these terminologies. We don't need to go through that in detail, but just to tell you that you have people talk about a P0 mild hybrid, a P1 hybrid, or P4 hybrid. It's only a question of where you place the motor. You can place the motor here, 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 or at the wheel itself. As you talk about movement from IC engines to electrification, you talked about hybrids. We talked about mild hybrid in the previous slides where we talked about a 48 volt system. There are other hybrid systems available. Some of them are called parallel, mild, series hybrid, plug-in hybrids, etc. The difference is only in the way power is transmitted to the wheels. In many cases, they are coupled either individually or together. And by means of software, by means of automatic clutches, you can actually control whether you want the wheels to be driven by the motor or by the IC engines. In a mild hybrid, for example, you have only a small motor, a 10 to 20 kilowatt motor. It does not do too much. It just does a stop start, it does a power assist, and does regenerative. The meaning of parallel means parallel is you can connect the motor, you can connect the IC engine either individually or together. In the case of series hybrid, it's also called as range extender. The IC engine is not mechanically connected to the wheel. This is a big difference. So please remember a simple example. Parallel hybrids, whatever name you call them, it is connected either parallelly or individually to the wheels. So you have an IC engine connection to the wheel, you have an electric motor connection to the wheel. In the case of a series hybrid, the mechanical system, which is the IC engine, does not have any connection to the wheel. It is driven by the electric motor only. So what does the engine do here? The IC engine here is actually used to charge. It works as an alternator, it works as a generator. It charges the battery. So when the battery becomes insufficient, it charges the battery. There's no mechanical connection. Plug-in hybrids are a last one you see here, plug-in hybrids are a method of series hybrids here. The only difference is in the case of plug-in, you have a system where you can actually plug as very obviously, you can plug it into an electrical outlet and you can charge the batteries. You can imagine here, the size of the battery depends on what type of hybrid configuration we are talking about. Today, we started at 12 volt, then we talked about 48 volt. Then we are talking about higher voltages today. What is driving this higher voltage? The higher voltage is driven basically because of the size of the motor that we need. We are moving from, we talked about pure IC engines, we talked about 48 volt mild hybrids, and we talked about different types of hybrids. Here we are moving towards a full-fledged battery electric vehicle, or a BEV as it is called, the bus voltage, 500 to 800 or 900 or 1000 volts, etc. These are all determining the size of the motor that you can have. Today, you've got cars which have got 100 kilowatts. You have an IC engine. You take some of these big SUVs today, they are at 100 kilowatt power. You can't use an electric motor of 10 kilowatts there. If you need to have a similar performance, you need to have a 100 kilowatt or equivalent. There's something which delivers an equivalent torque of a 100 kilowatt IC engine. It need not be the equal number in terms of kilowatt, but you need to have a similar sort of torque being generated at the motor which goes to the wheels. So that is only possible if you can have a higher battery voltages. As all of you, some of you must be electrical engineers also here, you must understand quickly that the power is greatly dependent on the voltage of the system. So if you have higher voltage, you have a chance of operating with a smaller envelope. You can have a bigger motor there which can drive the system. Now, this is typical of a BEV, or a battery electric vehicle. Okay. Here, this is called as a skateboard design. This is a chassis of a electric vehicle. Okay. Unlike a typical other chassis that you see here, this chassis consists of only battery packs. Okay. That's how it is. The entire battery pack is sitting below you. If you sit in a Tesla today, you will see that the battery pack at the bottom, it's below your seat. The entire space is occupied by batteries. What types of batteries are there? Today you've got lithium-ion batteries, but going forward, people are talking about multiple levels of development, solid-state batteries or lithium-ion, etc. What are the technology driving it? If you see today, the differentiator for IC engines today is, when you talk about two vehicles, you compare two vehicles and say, okay, which vehicle is better? You obviously say, this vehicle produces more, has more power, produces more torque. So that vehicle is better. Like that, what will be the differentiator for electric vehicles? It will be, obviously, the cost will be a differentiating factor. More importantly, the range. Once I charge it, how much I can travel using one charge is going to be a determining factor. Okay. After that, what happens? How much time do I need to recharge it? This is going to be very important. So basically, you're talking about cost of battery, we're talking about range, we're talking about recharge time. In terms of cost today, people believe that when you reach around $100 for a kilowatt hour, they think this is a threshold. We are not there as yet. If you reach this point, they believe that the trade-off between IC engine and battery electric vehicle will be completely taken away, and electric vehicle will become as popular as IC engine vehicles today. So the $100 is a number you can remember. People say this is the threshold. We don't know. We get to see when it happens. I've shown here some list of major battery manufacturers. You know why I have done that? The reason is very simple. Newer players are coming with newer technologies. As newer technology happens, newer players are coming. We don't have a Daimlers, you don't have a Peugeots, you don't have Seat, Hyundai, Kia, etc. You have got major battery suppliers becoming dominant. You got Panasonic, you have LG Chemical, you have got BYD, you got Samsung. These people are now starting to command in the market, in the battery market. They are trying to command how things are going to move. So we talked a lot about IC engines, we talked about hybridization, we talked about electric vehicles. We now talk about autonomous vehicles. We'll quickly go through all these things because we need to talk about more important topics also here. We're running out of time, I know. Autonomous vehicles. What is the meaning of autonomous vehicle? Autonomous vehicle means there is no person to drive the vehicle. It can automatically drive on its own. There are various levels of automation possible. There are 6 levels actually, starting from level 0 to level 5. Level 5 determines actually the highest level of automation, which means no human interface at all. The vehicle will move on its own. It will stop on its own. It will do whatever you want it to do. Now, how does all this happen? You can see all these vehicles are fitted with a huge suite of LiDARs. LiDAR is a ranging system, cameras, radars, microphones. It's like the human being. It's like the 6 senses or the 5 senses that you have. You have sensors for each one of them. And you've got algorithms. You've got software sitting inside the vehicle, very powerful, very strong software sitting inside the system, which actually tells you what to do next. When you see this, what to do next. I have information coming from my LiDAR here. I have information coming from my camera here. What to do with all the information is managed by this software sitting inside. Very powerful software. When I say software itself, you can imagine the people who are leading this have to be something to do with software. As you can very well say that the leader in autonomous vehicle development today is Waymo. And you know what Waymo is? Waymo is a subsidiary of Google, Alphabet. So Google today is one of the leaders in autonomous vehicle development. This is a picture of their vehicle running. There are other people here, a lot of people who are working, for example, Argo. Argo is another company. They have now tied up with Volkswagen. General Motors have got their own subsidiary called Cruise, which talks about autonomous vehicle development. So these are all people who are well versed in software, hardware, electronics, who are making a big splash as far as autonomous driving is concerned. The traditional players are not there today. Do you know something? The market cap of Tesla, electric vehicle Tesla, exceeds that of all the major manufacturers of automobiles made today. It exceeds Toyota's, Volkswagen, everybody's. And people are still saying Tesla is not making profit. The next big trend is connected vehicles. So we talked about electrification, we talked about autonomous driving. The next big trend is connected vehicles. What do you mean by connected? Connected is vehicle-to-vehicle communication, vehicle-to-cloud communication. You've got so much of data coming from vehicles. You see, I have shown a picture of a highway here. This is no more than just a plain highway. It is a data highway. It's an information highway. So many data, so much of data is being produced by all of them. We now are getting into a field of big data. Somebody needs to start analyzing this data, decide what to do with the data next. When I talk about connected vehicles, I'm reminded of a very good story I heard. Somebody was narrating it to me a few years back. Very interesting, I will tell you that. See, this gentleman is from the US. He's used to very, very luxurious cars like Lexus, etc. And he saw all this hype about Tesla. So he said, okay, let's try one Tesla and go. So he bought a Tesla, started using it. Now he went somewhere, he had a problem midway, he stopped. So as usual, as in any vehicle, you have got a number to call. So he called that number and they directed him to 2-3 people and finally landed at the desk of a lady. The lady kept talking to this gentleman and asking him, can you explain this? Can you explain that? All that. Now he thought he was talking to a call center. He's getting very upset. He's used to luxurious cars, something like Lexus, etc. And previously, if he had a problem with the Lexus car, immediately Toyota would rush. Many of the service people there bring another car and say, sir, use this car till your vehicle gets repaired. We'll repair it, deliver it to your house. Till such time, we are sorry for all what happened. Please use this. I think somebody is playing on the screen. Please don't do that. You are here to listen to a presentation. Please listen to that. Thank you. So this gentleman was saying, did I make a mistake? I'm used to driving Lexus, etc. I was so happy. Did I make a mistake in buying this vehicle? So is it wrong? He was thinking so many things. So after talking to some time, the lady said, sir, you can now start using your vehicle now. The gentleman said, what do you mean? He said, no, sir, you can start the vehicle, you can start driving it and take it away. So he did not know what happened. He went and sat in the car, he switched it on, started running, it ran well. He asked then, what happened? He said, sir, we connected to your vehicle and we find out what was wrong. There was a patch that needed to be updated. We updated that patch and the vehicle is running. Later on, he found that he was talking to one of the chief engineers in the R&D department. It is no longer a small call center. What it tells you is the possibilities are infinite. Just imagine, I can sit here, I can see what's happening to my car or my customer's car or my user's car or user vehicle several thousand kilometers away doing some operation. I can check it from here, and if there are any problems, I can actually fix it. What does it all lead to? It leads to smart cities. It leads to a good traffic management, greener environment, no pollution at all, reduced pollution. Now just imagine, a lot of these cars are going in one place. You get a communication saying that hundreds of cars are parked here. Suddenly the traffic can change and start allowing these vehicles to flow through. You have better traffic management now. So connected vehicles are going to be in the future. Benefits of connected vehicles are huge. It is happening. We are tapping a lot of it. We are going to continue also. Now, one reason why automotive industry continues to progress even today is because of the electronics. If we do not have electronics, we would not be continuing here. Electronics have a major role to play in the progress of the automotive industry. Embedded software that we have here is high-level software, very, very powerful, very good performance. Now, it'll not be wrong to say that today's car is actually a computer on wheels, and even a small car has got something like 30 or more computers sitting inside. And then you can see some of these high-performance cars. They have even 100 microcontrollers inside, 100 computers sitting inside. And if you were to connect all of them with wires, you would need hundreds of kilometers of wire. So what do? They don't use that at all. They start talking to each other through a controlled area network called CAN, like this. You don't have wires running everywhere. You have one simple connection. You have what is called as a CAN bus. You start putting information. Somebody puts in information. Somebody takes it out. For example, vehicle speed. So many people, so many controllers in the vehicle may read information on what vehicle speed you're running at. So what do? Do each of these controllers have a separate vehicle speed sensor? No. You have only one speed sensor. And what happens is that speed sensor, that information is shared. So one controller picks up that information, it puts it on the CAN bus, and somebody else takes it from there. Okay. So you see the efficiency now. We are now moving into an area where more computerization is happening. We have got a lot of information being shared, and all of that is being done in a very seamless way. This was a presentation made by a leading manufacturer a couple of years back. What are they saying is going to be the future? They're saying we are going to bet on all of them. We are going to bet on combustion engines, which is gasoline, diesel. We are going to talk about combustion plus electric. And we're also going to go electric plus hydrogen cell. So they're saying we're going to talk about all of them. We see a merit in each one of them. They see a benefit in each one of them, different areas, different places where they will operate. So it is to say that IC engine will continue, electrification will come, everything will have its place in the industry. Okay, now coming to the last part of my presentation, we talked about emissions, connected vehicles, electrification, etc. Now, challenges. What does all this mean now? Now, you see, new technologies coming in means new business models are there. You have a shift to alternate powertrain like zero emission vehicles, electrification. You need infrastructure for that. People need to invest in that. Investors, who invests in that? Everybody needs to invest. It's not only government. Government needs to provide infrastructure. Industry needs to provide R&D facility, need to invest in R&D facilities. All this is a major challenge for us. The next major challenge is climate goals. You know, global warming, we talked about one thing, zero emission vehicle, reduce the greenhouse gases, health challenges are there, particulate numbers should be low. All these are bringing about a different way in mobility. Societal changes, I talked about it. You know, shared mobility. You know, people, until recently, people were commonly using Ubers and Olas and everything else. After the pandemic, people are not willing to share, but I think it'll also change. It'll change. We'll get back to the old system when you have a medicine or a vaccine or something like that. We'll continue to have mobility. Today, some of the newer generation people don't want to own cars. They just want to use it as a service. That's why I said mobility as a service needs to be popularized. Globalization and rise of new players. I talked about new battery manufacturers. Who knew about Tesla until a few years ago? They were only doing experiments, that's all. Tesla today is a big player in the automotive industry. What does all of this mean? It means a big change in the labor market. People need to be reskilled, need to be trained. This is what is going to be a challenge as we go forward. We talked about the changes expected. What does it mean for individuals? For example, if you take a service like moving towards electrification, it will lead to a demand for engineers with a lot of software skills. The old system of jobs linked to production of conventional powertrains is going to change if you go in for electric vehicles. Somebody said that electric vehicles have got 20 moving parts as compared to 2,000 parts in a IC engine vehicles. In the beginning of the presentation, I talked about 49% of the GDP, manufacturing GDP, comes in the automotive industry. I also said it provides jobs for 37 million people. These 37 million people today are involved in manufacturing, servicing, supply chain, so many things related to the automotive industry. Suddenly you will find many of these jobs are no longer there. A different skill is required. People are moving from mechanical electronics to mechatronics. It's like, cricket. If you take cricket today, a good example is cricket. T20, today's games. IPL is going to start in the next couple of days. You got T20 games. You can't get into a team if you're only a batsman. You can't get into a team if you're only a bowler. You need to be more than that. You need to have multiple disciplines. You need to be able to bat and bowl a little bit. You need to bowl or bat a little bit. You need to be an all-rounder. I don't want to say all-round at a macro level. You need to be depth, but you need to have multi-skills. Electric vehicles will still need mechanical engineers. The reason I'm saying that is, we should not think that even if electric vehicles come, mechanical engineers will lose their job. No. There are many parts of electric vehicles which still use mechanical systems. You've got wheels, you've got rims, you've got tires, you've got wipers, ACs, air conditioning, everything you have. But the biggest requirement for mechanical engineers electric vehicles will be heat transfer. In a typical IC engine, you've got these radiators, you've got a water pump, etc., which manages all this. People don't even realize that. You put water once and then you forget about it. But here, electric vehicles, all this voltage changes. We're talking about 800 volts in a car. It produces a lot of heat. This heat has to be dissipated. And the best people to do heat dissipation are mechanical engineers, because mechanical engineers understand the concept of heat transfer. They know. They must be studying that in the 3rd or the 4th semester. So they know more about it than anybody else. So mechanical engineers have a role to play even there. Digitization. In India, because we started very late, we can adopt many of these things. We can go into digitization at large scale much earlier as compared to anybody else. Data analysis. If you have connected vehicles, you've got telematics in place, a lot of information is going to be produced. Somebody needs to sit, somebody needs to analyze the data, somebody needs to come up with algorithms to pick up this data. India is very strong in electronics and software, and we should be able to prove our mettle by working on data analysis. So what do we need to do? As human, as engineers, as industry, as people, it's common. It's not only about engineers, it's not common about only college students, it's about everybody else. We need to be able to understand and respond to trends. Today there's a pandemic, but tomorrow it will be back to normal. But normal will be no longer it will be a new normal. We need to know how to respond to that. We should be connecting academia and industry very closely. There's no use in academia working on its own, industry working on its own, not knowing each other what they're doing. Invest heavily in R&D. This is for both companies, government, everybody. We need to invest in R&D. We need to translate all the knowledge that we possess into intellectual property. You have all these many companies in the Western world who own these intellectual property, and that's why they're charging us. They're charging us for everything: licensing, copyright, protection, everything they do. And what do we do? Nothing. We just buy this. It's easier for us to follow them. That's not good enough. If we have to go forward, whatever knowledge we have, we need to be able to translate it into a product, into an intellectual property that can be protected, property that we can own. We need to own intellectual property if we have to become big as a country, as individuals, as a company, everybody. Specialization in multidisciplines, I talked about it a short while ago. Reskill people, reskill development, connected vehicles. What is the requirement for EVs? What is the requirement for connected vehicles? We need to talk about all that. Practical on-the-job training, apprenticeship. I think it's very important. We should not say that as soon as they leave college, they get into a job. Are they good enough? People keep saying they're not good enough. But that's no excuse, no? You need to be able to make them good enough. The only way is to have on-the-job training, talk about apprenticeship, people spending some time of their life, some time of their college career, doing some on-the-job work. Automation, electronics, that's where the new jobs are coming. We need to be able to possess knowledge to handle that. Okay. The last slide for me, I think India is on the cusp of some major developments. IC engines will continue to remain a major powertrain. Electrification will come sooner. We need to find unique solutions. I talked about the VUCA world. In the VUCA world, we translate VUCA into value and unique. We need to provide unique solutions for India. Frugal innovation. India has always been known for frugal innovations. That will be the key to success. If you have to become strong, we have to become good, we need to come up with innovations in a very frugal way. India is expected to do very well because we've got a good pool of engineers. Only thing we need to direct the engineers in the correct way so that they go in the direction. And what do we need to do? We need to develop these solutions very quickly. Okay, ladies and gentlemen, thank you very much. Thank you for your attention. With this, I finish my presentation.
You can stop sharing. That was mind blowing, really. Are you able to hear my voice?
Yes, I can hear you.
Yeah, it was amazing, amazing, really. I really liked it, and all the participants also would have liked. And if at all you have any questions, participants, please type your question in your chat box and also give your feedback about the session in the chat box. You are able to see, Viswanath, the chat box?
Yes, I'm able to see it. Till now, I have not seen any questions.
Yeah.
Let me see if there are any questions I can pick up from there and answer. I know we have covered a lot of topic in a very short time, but I think I was just trying to give a flavor of what to expect going forward. But I'm sure there could be multiple occasions when we can talk in greater detail about something very specific here.
Really, really, especially you were giving a lot of hopes for mechanical engineering students as well as the graduates, even the professors, that the branch is not going to die and they still have a lot of hopes for job opportunities. Wonderful, really amazing. Very good presentation, very good slides, and the way you explained, outstanding it was.
Now, there's one question here. Do you think industrial waste in the form of batteries would be cause of concern? Yes, the answer is yes today, but people will find a way to get over that. You know, you take even these lithium-ion batteries today, which we use in mobile phones. How to dispose them of is a question mark. People still are not very sure. I'm not even talking about batteries from automobiles. I'm just talking about batteries that we use in our mobile phones. Just imagine we sell millions of phones. Many batteries are just thrown away. So clearly, yes, it is a problem, but people will find solutions. Every opportunity comes with a challenge. Okay, how we resolve it is due to our innovation. What does post BS6 any country achieved? I think Europe today, as I said, is at Euro 6 and a little more. But now, instead of tightening on the emissions, more countries are now focusing on how to make our vehicle testing real life, how to conclude on RDE. They're spending more effort on making RDE more stringent, making fuel economy more important. Those are the areas that they're concentrating on, because I think emissions have come to a point where the investments and returns are smaller now. I think they'll focus more on fuel economy, or what shall I say, making real life emissions more appropriate. Okay. Do we get better efficiency with this vehicle if we were to, as if we were to use IC engine driven vehicle? Yes, it depends. You know, do we get better efficiency with this vehicle? I assume you mean electric vehicle. Now, yes, on one hand, answer is yes. As you said, if you look only at the CO2 generated by the vehicle, see, CO2 is nothing but CO2 is basically the efficiency of conversion, and CO2 is global warming, as I said. If CO2 is low, it means more efficiency. If you look only at the vehicle, yes, answer is electric vehicles produce zero CO2, so clearly they're more efficient. But that can't be the only judge. We also need to see where the power is generated. If you produce it in a very old power plant, then you lose efficiency there, which is worse than losing it here. You create pollutant elsewhere rather than here. You lose efficiency somewhere else. You create waste somewhere else. So I think we'll have to look at it in totality. We'll have to have a holistic view of it to see which technology is better for us going forward. Okay. I think we come to the end, Dr. Ushaa. If nothing else,
Any role of biodiesel?
Yes, biodiesel is there. Today, government actually promotes biodiesel, both for bio means bio for gasoline and for diesel. For diesel, it is called as biodiesel. For gasoline, it is called as ethanol blended. So there is some blending of alternate fuels there. Yes, it is there. There is a promotion. People are promoting up to B7 today. But really, where the feedstock comes from, is it more efficient to use it in diesel, is what is going to be the question. Actually, today's fuel requirement for BS6 includes biodiesel. Is biodiesel fully pollution free? The answer is yes and no, because you don't substitute the entire biofuel in diesel. It's not 100%. We never run at 100% biodiesel. It is only maybe blending 5 to 7% or maybe 10% of that. And then again, where the stock comes from, it's jatropha or rapeseed oil or what oil that you use for is becoming important. What actions you need to take so that the way the fuel is capable of being used is also very, very important. So the answer is biodiesel is not fully pollution free, but it is a good substitute for crude. For us, for India, more than the pollution, it is a question of reducing our dependence on crude oil imports. That's where the substitution with biofuel is becoming important. Industry 4 technology can be used in battery vehicles. Industry 4 technology is basically a manufacturing method. It can be used anywhere. Even today in our manufacturing industry, it can be used. What does it do? It uses a lot of these IoT systems. And as you know, vehicles, connected vehicles, electrified vehicles use a lot of these IoT sensors. And IoT sensors is the heart of an industry 4. So really, yes, it can be used. There are nothing to stop us from using industry 4 anywhere.
So thank you so much, Mr. Viswanath. It was a really very nice session and a lot of insights, even for non-mechanical people, in general, it was very informative. And thank you so much. Thank you, participants, for your patient listening. And we'll meet again in the next webinar. Thank you all. Thank you so much once again.
Thank you.